a sequence. Let's suppose you're given the sequence 5, 8, 11, 14. And you're asked to find out the nth term of this sequence. Well, the first thing to spot is that the sequence is going up 3 at a time. A nice, simple, steady increase. Now, the first big, horrible mistake that people make is they just say nth term equals, well, it's adding 3 every time, so n plus 3. That could not be more wrong. It's horrible. Please don't go there. Okay. Now, what we do instead is we ask ourselves, what do we know from our earliest years? What do we know that goes up in threes? And I hope the obvious answer is the 3 times table. Now, if I asked you to say the 3 times table, you would need to say this. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7, 3 times 8, 3 times 9, 3 times 10. You might stop there, but I would ask you to say all of the 3 times table. So 3 times 11, 3 times 12. You can't do it. It goes on forever, as you well know. But we can write it down if we're a little bit clever about it. If we're willing to use a letter to describe that 1 which changes into 2, which changes into 3, which changes into 4 as we move up through the table. If we're willing to use a letter for that number, then we can write the 3 times table like that. 3 times n. And so that n is representing any and all of the whole numbers. Perhaps 1, perhaps 2, perhaps 3, perhaps 50, perhaps 100, perhaps 1,000,000. And whichever number you choose, it's working out part of the 3 times table. And that gives us a structure which goes up in threes, which is what we need here. We need something that goes up in threes. So that's why the idea of 3 times n is so important. So that's our first thought. The nth term equals 3 times n. But it's not fully right, is it? Because that would give me 3, 6, 9. And I want 5, 8, 11. Now, a little bit of thought will tell you that we should add 2 onto the 3 times table. We should make it 2 bigger than the 3 times table. However, there is another way of thinking about it. What we can do is we can try to imagine what number would be sitting in that position just before the sequence starts. We know the sequence is going up 5, 8, 11. We count backwards in threes. This is the number 2, or more precisely, positive 2. And that is the number that we need to put on the end. So you can see then that just drops in there. So a slightly neater way of writing this sequence is that the nth term equals 3n plus 2. And you can check that you've got it right. For instance, this is the first term, second term, third term, fourth term. You can check it. Let's try n equals 4. If n equals 4, then the fourth term equals 3 times 4 plus 2. That does make 14, which is what it was supposed to make up here, and so we can be confident that we've got it right. And that's how you find the nth term of a linear sequence.